Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Dear students, let's understand what is the meaning of composite function. Let f from a to b and g from b to c be two functions on non-empty sets a, b and c. Then what is GOF? GOF is a to c. Alright, so GOF from a to c. So if f is from a to b and g is from b to c, then GOF will be a to c, the first and the last sets. Is called composite function, and it is given by what is GOF, that is nothing but g of f of x for every x belongs to a. So from where do you select the values of x here? From the set A, domain of f. So that is about the composite functions. So now what do you mean by inverse of a function? Inverse of a function f from a to b is f inverse from b to a. And when do you say inverse exists? If two conditions, if the condition if two conditions satisfy. The first of all, the first condition is GOF must be identity. GOF must be identity for the set A, and FOG also must be identity. Okay, so now what is G? G is nothing but f inverse. I'm sorry. So f inverse of f must be identity, and f of f inverse also must be identity, because f inverse begins with b. Okay, the domain of f inverse is b, therefore it must be identity for the set B. Now if these two conditions satisfy, then inverse exists, and inverse is given by f inverse of y is equal to x if and only if f of x is equal to y. Okay, so here domain and codomain change. Look at this, here the domain of f is a, so f inverse domain will be b, reverse. Okay, so similarly the codomain is also interchanged, so therefore the values will change. Let's understand graphically. You have the x values here. Okay, so when you go here you get y, that is f of x. So that same y, when it comes here, it becomes f inverse of y, and what is it? X itself. Alright, so f inverse of y is in A and f of x is in B. F of x is nothing but y, x is nothing but f inverse of y, so they are in the domain. Okay, so what is the domain for f inverse? When we come back, this is f inverse, therefore domain of f inverse is B, and the domain of the function f is A. So that's the logic. Keep that picture in your mind. Now let's solve a few questions regarding the composite and the inverse of a function. We are solving the examples of composite and inverse functions. Let's look at the first question here. If f from real numbers to real numbers, g and h all are from real numbers to real numbers, and how they are defined: f of x is x square, g of x is tan x, and h of x is log x, then the value of h of g of f of x if x is equal to root pi by 2 is 0, 1, minus 1 or 10. So these are the options that you have got. Let's begin with this. So we have to find h of g of f of x. Now what about h of g of f? So that is h of g o f of x. Now that is nothing but h of g of f of x. Right. Now let us substitute f of x. Alright. So what is f of x here? F of x is x square, right? So first you have h of g of x square. Now let's continue. See, I have just replaced f of x with x square. Now next, what is g of x square? Look at this, g of x is tan x. In place of x you have got x square here. You just have to substitute x square in this place. So that would be h of tan x square. Now next, you got to look at h of x formula. What is h of x? Log x. So in place of x we have got tan x square. Therefore that would be log of tan x square. So log of tan x square. Now what is the value of x given? Root pi by 2. Let's substitute. So let us substitute that log of tan root pi by 2 whole square, right? So that is log of tan root pi square is pi and 2 square is 4. And what is tan pi by 4? Tan 45. Tan 45 is 1. So this is log 1, and log 1 to any base is 0. Log 1 is 0 for any base, and hence the first option is the right option. Well, let's move on to the second problem. Look at the second problem. You have got f of x and g of x. We need to find f of g of x, and that is equal to 25. We have to find the values of x. So let's start with f of g of x is equal to 25. Okay, so this is like g of x. What is g of x? X square plus 7, and that's 25. Now you have to look at f of x formula. F of x is 2x plus 3. Now in place of x you have got x square plus 7. Therefore here also you must substitute x square plus 7. So start with 2, and in place of x you have got x square plus 7 and plus 3, that is equal to 25. Well, so 25 and minus 3, you have 22 there. Multiply this 2, so 2x square plus 14. Yes, so what is 2x square? 22 and minus 14, so that is 8, and hence x square is 4, which means x is equal to plus or minus 2, and that's in the second option. That's the answer we were expecting. Well, so those questions are very simple. Just you need to know the meaning of f of g, f o g. This is actually, but they have written in the form of f of g of x. Substitute g of x first, then use f of x formula to find the value of f of x square plus 7. Let's move to the third question. Well, so that is also based on the composite functions. So f of x is equal to ex, that is given to us. So let's begin with this, and now let me substitute f of x here, and that is ax divided by x plus 1, ax divided by x plus 1, where x is not equal to minus 1. Alright, so x is not equal to minus 1 in the denominator. Well, now what we need to find is the value of a. So value of a is what we need to find. Now use the formula f of x again. See, what is f of x? I'll write it here. So that is ax divided by x plus 1. Now in place of x, we have got this total quantity. So that quantity must be put here as well as here, right? So let's begin. Start with a and then ax divided by x plus 1, and here also ax by x plus 1 and plus 1, that is equal to x. I hope you understood, because f of x is ax by x plus 1. So ax by x plus 1, that is x. So that is the same thing. Now we got to simplify this total thing and find the value of a. Let's do it. So how do you do it? Multiply this, right? So that will be a square, and this total quantity you can bring it to the other side, or you can take the denominator, so that denominator gets cancelled. That's better. We'll take the LCM. Okay, so we'll take the LCM, that must be multiplied here. So this is ax plus 1 into x plus 1, 1 into x plus 1, that is x plus 1 itself. Now delete this, cancel this denominator, so that will be a square x divided by, yes, so ax plus x plus 1, which is equal to x. Now cross multiply, you will get the value of a. See, what you can do here is you can take x common. So if you have taken x common, what are you getting? A plus 1, right? Now you can go through the options and put appropriate value so that your answer is x. Where you have to put? You have to put in the place of a. So start with root 2. Root 2 square is 2x, and this is root 2 plus 1. It doesn't simplify, doesn't get cancelled. You are left with the 2x divided by root 2 plus 1 x plus 1. You can't simplify and get x there, right? Minus root 2 also doesn't work. 1 or minus 1. Now if you put 1 here, so that is 1 square, fine, 1x, that is only x, divided by, see, this must be 1, so that x by 1 is x, correct? Okay, so do you get 1 here? If you put 1 plus 1 is 2, so 2x plus 1. So x divided by 2x plus 1 is not x. So last option is minus 1. Now if you put minus 1 whole square is, okay, so if a is minus 1, then that will be x, and this is minus 1 plus 1 is 0. So x into 0 plus 1, so that is x by 1, which is x. So that's the answer we needed to get, okay, and we got it. Therefore, which value of a gives you the right option, right answer, that is minus 1. We are solving the examples of composite and invertible functions, and we are in the fourth question. If g of x is equal to x square plus x minus 1 and g of f of x is equal to 4x square minus 10x plus 5, then find f of 5 by 4. See, f of 5 by 4 is not directly given, but it is implicitly given here in the composite function. We got to find that, and these are the options that are there. Now what we will do first is we shall find, see, you know, f of 5 by 4 is what you have to find. So let us find g of f of 5 by 4. We can substitute that here, right? So I'll find that. We may need it later. So what you need to do is, in place of x, substitute 5 by 4. That's it, right? So this is 5 by 4 square minus 10 into 5 by 4 plus 5c. What are you getting here? See, this is 5 by 16, so 5 by 4 basically, right? And this is like 2 and 5, therefore 25 by 2. Yes, and what is this? 5 by 4 minus 25 by 2 plus 5. So you can take the LCM 4 and that will be 5 here, minus 50 plus 20. So this is like 25 minus 50 by 4. So that is, yeah. So this is minus 25 by 4, correct? So that is minus 25 by 4. Let's check again. See 5 square, I'm sorry, that's the mistake. That's where we went wrong. See, this is 25 by 4, alright. So this is 25 by 4. So that is 45 minus 50, that is minus 5 by 4. Well, so see, what did we get? We got this value. Now what we can do is we can find g of f of x using this formula. See, I'll tell you how. Just look at these two things. Okay, just look at these two things. G of f of x is this, correct? Alright, now you have got g of x, in place of x, you have got f of x. So what am I writing now? I am writing g of f of x using this formula, okay. So in place of x I am going to substitute f of x. So in this place of x I have to substitute f of x. So that is f of x whole square and plus f of x and minus 1. I hope you understood this. G of x is this, g of f of x, in place of x put f of x, in place of x f of x, in place of x f of x. That's it. Now the work is so much easy. Okay, so next see, we know this value. So what we will do is we'll write g of f of 5 by 4, that is in place of x there is 5 by 4, so here also 5 by 4 and this is whole square plus f of 5 by 4 and minus 1. Well, now what is the question? Question is to find f of 5 by 4. Alright, so f of 5 by 4 is what you have to find. So now see, this value we know, we'll substitute. So before that, let f of 5 by 4 be y. Then see, this value is minus 5 by 4, that is minus 5 by 4, and this I'll take it as y, so y square plus y minus 1. So that gives me a quadratic equation which can be factorized and we can get the value of y. In other words, we can get value of f of 5 by 4. That's the question that was asked to us, right? So we are very close to the answer. Now see how we will continue it. Okay, so this is y square plus y and this becomes plus 5 by 4 and this minus 1 as it is. What I am doing, I am just shifting this to the right hand side and writing that whole equation on the other side. Now this is y square plus y and take LCM 4, 5 minus 4, 1 by 4. Well, now this is like y plus half whole square, is it not? Or you can use the quadratic equation formula, y is equal to minus b plus or minus square root of b square minus 4ac by 2a. That formula also you can use here, there is no problem. Okay, but if you are using a simple method, you can do this. Okay, say this is y plus half whole square. How? A square y square plus 2ab, 2 into y into half, this cancels, you get y, and half square is 1 by 4, right? So now if the square is 0, then y plus half is also 0, which means y is equal to minus half, which means f of 5 by 4 is minus half. So that's the answer. Okay, so f of 5 by 4 is minus half. Let's move on to the fifth question. The fifth question. Fifth question, which of the following functions is not invertible? Well, now we are moving in with the invertible functions. When do you say a function is invertible? Alright, there are two definitions. One is a function f from a to b is invertible if there exists a function f inverse, or you can say g also. I will take f inverse from b to a such that f inverse OF should be identity for a, and f of f inverse must also be identity, and that is for the set B, because domain of f inverse is B. Well, so if these two conditions satisfy, then f inverse from B to A will be the inverse of the function f from A to B. That is the first definition. Or there is another definition, f is invertible f from A to B. Okay, understood. If and only if it is bijective. Alright, so these are the two definitions that we have to remember. Now that question can be tackled using the second definition. You don't have to do f inverse of f and find f inverse first and then do this. So you don't have to do that. You just have to check whether it is both 1 1 and onto. If it is both 1 1 and onto, it is obviously invertible. So that's what we will do here. Right. So first you have got f of x 3x plus 1. Alright. So if you have f of x 3x plus 1, f of a is equal to f of b. If you take, that is 3a plus 1, 3b plus 1, 3a is equal to 3b. That means a is equal to b. So f of a is equal to f of b implies a is equal to b, means it is 1 1, and it is y. It will be on to c y. Okay. So 3x is equal to y minus 1, x is equal to y minus 1 divided by 3, and it belongs to the domain. It belongs to the domain R. So hence it is onto as well. So it is both 1 1 and onto. Therefore the first function is invertible. Why? Because it is bijective. If a function is bijective, then it is invertible. What about the second? F of x is equal to x square, and it is defined only on 0 comma infinity, only positives. So you have got only the positive values here. You don't have the negatives. You have all the decimals. Okay, so you have negatives, you have 1.1, 1.2 and so on. Okay, here you have got only positives. Alright, and you have all the decimals here, all the real numbers. You can't write these actually, just for representation I am writing a few values here. Okay, you even have 0.1, 1.5 and all those values are there. Okay, every decimal is there, every real number is there. Now what is the function x square? So minus 2 square goes to 4 and minus 1 square goes to 1, 0 square and 1 goes to 1 itself, right, and 2 goes to 4. It goes on like that. Now see what number will come here, root 3. So root 3 will go to 3. So what about the other values? Every value will have a square root there. See, understand? See, when x goes this side becomes x square. If you have y, when it comes back it is root y, correct? Okay, so root 2 will go to 2. So if you have y here, then root y will be here, correct? So that is the inverse function, that is the inverse function, f inverse. Does it exist? Yes. And do you think root y is defined? See, what is f of x? F of x is x square. If you are following the onto method, see, is it 1 1? Yes, it is 1 1. And do you think it is many one? Do you think two values are going to one single outcome? Yes. Okay, so let's check onto. I'm diverting, I'm sorry. So this is y is equal to x square, therefore x is equal to root y, and does it belong to the real for every positives? For every positives, correct? So y belongs to the positive real numbers, therefore there is no question of getting square root of negative. So it will belong to R, it will belong to R. Hence that will be onto. But what about 1 1? Understand, f of 1 is 1 square, which is 1. F of minus 1, that is minus 1 whole square, which is also 1. That means 1 and minus 1 both are going to 1. So it is many 1. If it is many 1, then this is not invertible. Alright, this is invertible, therefore the required answer is not invertible. This is not invertible. What about the next? This is invertible because it is from positives to positives. Okay, it will be both 1 1 and onto. There is no question that two values are going to one image, because if you are putting negative, the answer will be negative. If you are putting positive, the answer will be positive. There is no question that positive and negative like this will go to a single image. I hope that is clear. Okay, so option B is not invertible because it is not 1 1, because it is not 1 1. Move to the sixth question. If f is an invertible function defined as f of x is equal to 3x minus 4 by 5, then what is f inverse of x? It is invertible. You are able to find the inverse, then find it. That's what they are saying. Okay, so if it is invertible, then what is the inverse of it? So let's do that. F of x is equal to 3x minus 4 divided by 5. See, you have got x here and that has become f of x. So that is nothing but y. Now what will happen to y? So that is the inverse, that will be the inverse function when we come back. Okay, so take this as y, 3x minus 4 divided by 5, that means 5y, 3x minus 4, that means 5y and plus 4 minus 4 when it comes here, And now what is x? Just divide this, okay, on the other side. Therefore, finally x is equal to 5y by 3. Now what is g of y? See, when we go this side, it is f of x. This is y, and when we come here, it will be g of y, correct? So this is a function of y because it is in terms of y. And what is it? 5y plus 4 divided by 3. What is g? F inverse. So that is f inverse of y. Now we need to find f inverse of x. So just you have to replace y by x, that's it. So what is f inverse of x? That is 5x plus 4 divided by 3, and that's in the option C. So option C is the right answer. Let's move to the next question. And now we are solving the examples of composite and invertible functions. Now we are in the question number 7. Let's look at it, okay, and solve it. Consider the function f in the set A. So what is the set A? All the real numbers except 2 by 3. Because if you put 2 by 3 here, yeah, what will happen if you put 2 by 3? 3 ones I mean yeah, so 3 2s are here, 2 into 2, 4 minus 4, you will get 0 if it is 2 by 3, correct? Okay. So if the denominator is 0, then f is not defined. So therefore you don't have 2 by 3 in the domain of f. Let's continue. What we need to find? F inverse. Okay. So this is in terms of x. So f inverse of x is what you have to find basically. So let's start with that. F of x is equal to 4x plus 3 divided by 6x minus 4. Now take it as y, and y will be 4x plus 3 divided by 6x minus 4. Cross multiply. Alright, now multiply this. So that will be 6xy minus 4y, and that is equal to 4x plus 3. What we need? We need to express x in terms of y. So we need x basically. So what do we do here? Alright, so you have 6xy, that will be minus 4x, and this is 3, and you will have plus 4y. Now take x common. So if you take x common, 6y minus 4, which is like 4y plus 3, or you can write as it is, okay, no need to change. So 3 plus 4y, and this is 3 plus 4y. This part will be divided on the right hand side. So 6y minus 4. That's it. That is x. And what is x? G of y. Correct. So this is a function of y, and that's the inverse. Okay, that's the inverse. So 3 plus 4y divided by 6y minus 4. Now what you need is f inverse of x. Okay, g of y is nothing but f inverse of y. Alright, so that is f inverse of y. Now if you need f inverse of x, if you need one more step, I will write it. So this is 3 plus 4y and 6y minus 4. So that is g of y. G is nothing but f inverse. So f inverse of y. Okay, so straight away you could write f inverse of y also. Now what is f inverse of x finally? So that will give you the options here. Okay, so 3 plus c, in place of y we have x, so substitute x. So this is 6x minus 4. Okay, so that is 4x plus 3 divided by 6x minus 4, which is the same element. Why? Because f of x Okay, so if you find this, you will get x. This is the identity function. So f is the inverse of f. Okay, f is the inverse of f. So which option is right here? So 3 plus 4x divided by 6x minus 4. First option is the right answer. Well, let's move to the next question, question number 8. Let f from R to R and g from R to R be two functions such that f of x is equal to 2x minus 3 and g of x is equal to x cube plus 5. The function f o g inverse of x is equal to. Alright, so what we need is inverse of f o g. Okay, this is what we need. So if you have FOG here, when we go back, that will be FOG inverse, that's it. Okay, so we need to find what is FOG. So we will find f of g of x. So that is nothing but f of g of x. Okay, so let's substitute g of x. What is g of x? X cube plus 5. And now we have to find c f of x is 2x minus 3. Now in place of x, I have got x cube plus 5. So substitute that here in place of x. So that will be 2 and then x cube plus 5 and minus 3. So that is 2x cube plus 10 minus 3, which is 2x cube plus 7, and that is f of g of x. Now from f of g of x, we need to find this. So how are you going to do that? So take it as y, consider this as y, and get x in terms of y. That's it. So this is 2x square. C x goes to f of x. That is nothing but y. So y, when it comes back, that will be g of y or f inverse of y. Okay, so you can find f inverse of x also. All right, now what is happening here is, see, you have the function FOG. So x goes to FOG of x. That is nothing but y. So y, when it goes back, it goes through this function. So it becomes FOG inverse of y. Correct? Okay, and that is nothing but x. So that's what we will find, x. That is nothing but FOG inverse of y. Then y can be replaced by x. That's easy thing. So now this is y minus 7 is equal to 2x cube. So what is x cube? This 2 must be divided here. Right, now you need x, so take cube root both sides. So this is y minus 7 divided by 2 to the power 1 by 3. So this is x, and that is nothing but FOG inverse of y, and that is y minus 7 divided by 2 to the power 1 by 3. Hence what is FOG inverse of x? You just have to substitute x here, and that will be x minus 7 divided by 2 to the power 1 by 3. So which option? X minus 7 divided by 2 to the power 1 by 3, and that's the option 4. That's the right answer. Well, so that's it for this class. In the next class, we will start with the new concept in relations and functions, and that is binary operations. So thank you very much for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.